So we're almost through. That was from 1.4. And solving fractions equations. Well, we can solve equations with fractions the way we have been, but there is a shortcut. We like those, right? Because nobody likes dealing with fractions, especially when we're already dealing with something complicated, right? So, and that's why in our algorithm, the first line says, simplify each side of the equation. 1a, if fractions exist. Yes. Here we have fractions. If fractions exist, we have two options. If the fractions are outside the parentheses, which I think all of mine are, and no, there's one, no, and these, I don't have any fractions inside the parentheses. That's even more complicated, but I finally wrote it in the algorithm. If it's outside the parentheses, we can deal with the fractions first. And that says, to deal with the fractions, multiply all terms on both sides of the equation by the least common denominator of all the fractions. Least common denominator, least common multiple of the denominators of both fractions. So my fractions, I have denominator 2, denominator 3, denominator 6. The least common multiple of those denominators is 6. And in fact, if I wanted to work it with fractions, I would have to change both of these so that they all had a common denominator. To find that common denominator, I would look for the least common multiple of the denominators. But here I'm saying, well, instead of rewriting it all in fractions with the same denominator, let's take that least common multiple of the denominators and actually multiply the entire equation through by it. When we do, it should eliminate the denominators completely. So, I multiply my whole equation through by the least common multiple of the denominators, which is 6. And then I could write it as multiply that side by 6 over 1 and multiply this side by 6 over 1. Well, here I got to distribute that multiplication. So I end up with 6 over 1 times x over 2 minus 6 over 1 times 1 over 3 equals 6 over 1 times 1 over 6. And then when I look at this, I see, oh, well, 6 is a multiple of 2. That's how we got it, right? Therefore, 2 divides into 6. So I can divide 2 out of the top and the bottom. On the bottom, I'll get 1. 1 times 1 is just 1, so my denominator disappears. 6 divided by 2 is 3, so I end up with 3x over 1, which is just 3x. Okay, minus, well, the next part, well, 6, have we found it? We said it's a multiple of that denominator, so 6 is a multiple of 3, which means 3 should divide out of it. So I can divide the top and bottom by 3, or just say multiply it out, which will give me 6 divided by 3, is going to give me 2. Because that'll be divided by 3 on the bottom, I'll get 1 times 1 is 1, over 6 times 3 is, 6 divided by 3 is 2, 1 times 2 is 2, 2 divided by 1 is 2, I'll get minus 2. And here, multiplying by 6, but 6 is a multiple of this denominator. In fact, it is. It's multiple 1 times 6. Multiply them out, they're going to divide out, and I end up with 1. So now by multiplying the whole equation through by the least common multiple of all the denominators, I have eliminated all the denominators and turned my fractional equation into a non-fractional equation. 3x equals 2, 3x minus 2 equals 1. You thought you were done with least common multiple. Now in practice, sometimes we don't want to. Mathematicians can be lazy. And sometimes I don't want to find the least common multiple. So what do? In practice, I'll multiply everything through by the largest denominator. And I'll reduce the things down. Now either that is will get rid of all my denominators, or it will at least get rid of the largest one. And it might reduce the others. Once I do that, if I still have fractions, then I'll multiply through by the largest denominator I'm left with. That'll eliminate at least one of them. And I can keep on in that manner until I get rid of all my fractions. Or I could just find the least common multiple of the denominators to start with, but I'm just saying. Okay, so now we just have to solve the equation. We know we've got to get the x term on one side and the constants on the other. So we've got to move this constant away, so I'm subtracting 2, so the opposite of that is adding 2, so I'll add 2 to both sides. Minus 2 plus 2 is 0, so I'm left with 3x equals 1 plus 2 is 3. 3x equals 3. 3 is multiplied by x, so I need to divide that coefficient away. So I'm going to divide both sides of the equation by 3. These will divide out. I'm left with 1x. And x happens to equal 3 divided by 3 is 1. X equals 1. And yes, then I could plug that back in and check it, but honestly, what I tend to do myself, it's not a full check, but I will tend to take my 1 and plug it back into the non-fractional part. It's not a full check, but it's part of a check, because I really hate doing those. Yeah. So 3 times 1 is 3, 3 minus 2 is 1, and 1 equals 1. So yeah, it checks out. Full check, but it's partial check. Okay, next one. I got a quantity divided by 6 equals x divided by 2 plus 3 divided by 4. Fractions, I want to get rid of them, so I'm going to multiply through by the least common multiple of all those denominators. 2, 4, and 6. Well, 2 is just 2. 4 is 2 times 2. And 6 is 2 times 3. To be the multiple, I gotta have a 2. In fact, I have to have 2 2's to equal 4. I'm going to bring down another 2. This one only has to have 1 2, and I've already got 1 2. In fact, I got 2 of them. I got one of them, then I just need the 3. So 2 times 2 times 3 is 12. So my least common multiple of the denominators is 12. I could have also put this other 2. Could have said 2 times 3 and said, oh, I got 1 2. Oh, I need another 2, and then I need a 3. That works too. So I'm going to multiply through the entire equation through by 12. So my first term, that thing has to be multiplied by 12. 12 is 12 over 1 in fractional form. Then this whole thing also has got to be multiplied by 12. I do it in the first term and the second term there. So I got 12 over 1 times x over 2 plus 12 over 1 times 3 over 4. If I did this right, I should be able to eliminate my denominators. 12 divided by 6 is 2. So I get 2 times x plus 5 equals 12 divided by 2 is 6. So I get 6 times x. Plus 12 divided by 4 is 3, so I get 3 times 3 is 9. Now I can do my distribution here. 2 times x is 2x, plus 2 times 5 is 10, equals 6x plus 9. Now we just want to get all our x terms on one side and all our constants on the other, so I decided to put the x's on the right. So I've got plus 2x, so the opposite of that is subtracting 2x, so I'll subtract 2x from both sides. So that's going to move my x's to the right, so now I need to move my constants to the left, so I've got to get rid of this 9. Adding 9 there, so I'll do the opposite, which is subtracting 9.